All right, guys, here with our AP Stat students, continuing going over our multiple choice questions. Today we're going to do 21 through 30. Let's start with 21. All right, so this question, as you read the answer choices, is really asking one specific question about your understanding of linear regression. And this question essentially says, do you remember what r squared is? You guys, well, let's just start, I guess, with the lowercase r. Do you remember the lowercase r? No one? Lowercase r? That's the correlation coefficient. Do you know what that measures? Bless you. Don't use the word in the definition.
How they're related to each other.
Okay, I mean, it's getting there.
Like how close they are in being the same? Or like, I don't know.
It measures the strength of the linear relationship between two quantitative variables. I'll write that down. I think I misspelled correlation. Does that look better? That looks worse. Anyway, it measures the strength of the linear relationship. Remember, it's always a linear relationship between two quantitative variables. I got a box of pencils back there. So that's the correlation coefficient. There's some characteristics you need to know about the correlation coefficient. Do you remember our boundaries of what it could be? Close, getting there. It can go below 0. Well, I'm saying when I look at the letter R, it should be between this and 1. -1 and 1, not negative infinity. When have we ever said the word infinity in this class?
I was just thinking of stats of pre-cal, sorry.
Yeah, that was so not this year.
No, I get that. I must have miscalculated.
It's okay. So it's between -1 or 1. If it is -1, or if it is 1, which are we really going to see that probably in the world? Probably not. But the closer it gets to those extremes, what does that tell you about the strength of that relationship? The stronger it is. All right. The closer it is to 0, the weaker it is. And then we would say that there's not a linear relationship the closer it is to 0. Okay. So remember those 3 different words we use: strong, moderate, and weak. All right. That's all about letter R. Okay. Now R squared, you take the letter R and you square it. I know, shock, awe, right? You square it. Do you remember what this says? This is called R squared. I don't have a fancy name for it. Okay. This measures the variation in Y that's explained by the variation in X. All right, so again, I cannot guarantee this in a few weeks, but as you can see with this question, right, they're going to ask you something about R squared. All right, so if you don't know that R squared measures the change in your Y that's explained by the change in your X, then you'll get that question wrong. Right? That's okay, it's just one question. All right, so in this question, we're looking at the relationship between the height and the age of a child. What do I know about those two variables?
They're correlated.
I don't know. Actually, it does tell me what the R is, correlation coefficient, but really they're just quantitative first, right? Because there's no reason to do the letter R, to do the correlation coefficient, if they're not quantitative, right? How do I know that they're quantitative?
They're numbers.
Yeah, be careful with that. Anyway, could I get a pass or anything? Go with what? Being tardy? No.
Yeah.
Okay. Do you have paper? Nothing? Okay.
You were to parents?
You will. Are you one of the leaders? It's going to be a long day then. Okay. Anyway, there's a paper there. I got pencils in the back. You got a sharpener there. You could participate. So we know these are two quantitative variables, not because they're numbers. Right? Can you think of the units? Can you think of the units? Not because they're numbers, because I can make data be numbers that are not quantitative. So what are the units? Just tell me. Make them up if you don't know. Inches, feet in inches, and years. Great. We made up units. Awesome, right? So that's what you want to make sure to do. Ask yourself, are these actually quantitative? They are. It says the correlation coefficient between them is 0.8. So R is 0.8. So how would you describe that in terms of the strength of the linear relationship between these two?
Pretty strong.
I wouldn't say pretty strong. I just say strong, right? It is strong. It's above. Usually my cutoff is about 0.8. So I'd say it's into the strong area. Okay? Now, what does it tell me R squared is? What's 0.8 squared?
1.6? No. 0.64.
Okay, good.
Wait, did I just multiply times 2? Yes. Yeah.
Pretty much, yeah.
Yeah, pretty much.
All right. And so this tells me that, and I'm going to read this statement to you, how I would think about this. All right. The key thing is I want to figure out what is my X and what is my Y. So what's my response variable? It says to predict the height of a child. That tells me the height is my Y, and they're saying the explanatory is the age. All right. So here's what I would write.
Good morning.
Good morning.
It's a big math.
It's not a big pass. But thank you for having a pass. I appreciate that.
Yep.
So here's what I would say. This is the statement that I had you guys write back in probably October. 64% of the change in a child's height can be explained by a child's age. 64% of the change in a child's height can be explained by a child's age. The key thing that I always look for is that explained by, right? That's what my statement always has. I really hope you guys didn't pick D or E, right? Have we ever said that the line can correctly predict things? No, right? You should always remember leaving this class that all models are wrong. Some of them are useful.
What was that word that you said means experiment?
Randomly assignment of treatments? Random assignment of treatments?
Maybe.
Okay, let's do 22. This is asking for the sampling distribution model of a sample mean. This is straight out of chapter 18. All right, the way you find this new model is it's going to be normal, all right, where we have our mean is the same, and the formula to find the new standard deviation is your sigma over the square root of your sample size. And that is on your formula sheet. All right, so what is going to be our mean? It's going to still be 11.4.
Yes.
All right, so it's A or B. And which one shows you the original population standard deviation divided by the square root of the sample size? Is B. Excellent. Hopefully we get it right in a few weeks, so we're not guessing. Now, when I say a few weeks, I really should say 9 days.
When is it?
Wait, what?
Yeah, it's next Thursday.
Like not this Thursday, but next.
That is correct.
We go.
I thought I had time to prepare.
We take it in the morning.
Well, you take it in the afternoon, Marco, so at least you have time to prepare.
A whole year.
Yeah, so
In 2 hours.
next Thursday.
Don't college students do that for their thesis or whatever? It's possible.
Well, their thesis is senior year.
Yeah, but like they all write it in like 2 days.
Thursday the 5th.
Because that's like their annual
I don't know what you're trying to prove here.
experiences.
So many things you're saying are incorrect. Let's just move to the next one.
Wait, what was it?
Number 23.
Do you know even like every only if you're doing a PhD or a master's?
Are you talking about a thesis statement in papers? Or are you talking about
Like their
to defend for your PhD? Yeah, it's not undergrad.
Oh.
So many things, right? Just live your life. Live your life. Senior year.
Oh yeah, senior year of college.
Nope.
Your last year.
Nope.
What? And when is it?
When you get your PhD. So usually people go senior of college to get their bachelor's. Then they go back to grad school for a few years to get their master's. Then they go back again to get their PhD.
So you only have to do a thesis if you're doing it.
That's my understanding. But again, I have not lived a whole life. Let's keep going. 23. I'll be honest, this one got me. I missed this one. I know. I got this one wrong. Yeah, I did. It's okay. It's okay. I thought it was B. It is wrong. Let's make sure we know why it's not B.
It's E.
Let me make sure why. Hold on. Okay. First thing is, when you're looking at a z-test for proportions, this is mean, so you can figure out, okay, are we talking about proportions? Are we talking about averages? We're talking about averages, right? The average difference in the number of cars parked, so it's not A. Okay? Number of cars parked is quantitative, so it's not going to be chi-squared, because chi-squared is categorical. So it's between a two-sample t-test or a matched pairs t-test. I thought it was B, but here's why it's not. Okay? The reason it's not is because when they did their random sampling, they chose the same 15 school days for both schools. All right? So that matches them based on how they decided to sample. All right? So in this case, it is C, matched pairs t-test. Probably because I had 3 kids on the couch watching TV. You know, my son in the other room playing on his iPad. Just trying to get some work done while all the kids are sick. Questions on 23? Oh, I mean, I just made a mistake.
I was just asking, so how did you?
I'm not perfect.
No, I get it.
Let's do 24. All right. This is asking for the interquartile range. Interesting. Do you guys remember the interquartile range?
Yes.
Quartile 3 minus quartile 1, right? This is not basketball. We're talking about quarters. Quartile 3. Excellent. It's okay if you think that though, right? Because it is about 25%, 75% of the data. Now, they did you a favor here. They did you a favor. The sample size is 100 men, right? The reason that's doing you a favor is because you're looking at quartile 1 being the 25th data value and quartile 3 being the 75th data value. So you can literally just count.
1, 2.
Let's not do that, right? Let's add them together. 1 plus 1.
2.
2 plus 2.
4, 6, 9, 13,
18,
Almost.
32.
Right there. 66. Well, it is 32, but that's where the 25th number is. It's 66. That's quartile 1.
Now, do we go backwards?
I'm going to do that because I'm just going to count 25 from the top. But if you kept going, you would keep going until you got to 75. Your choice. Get the same thing. 1 plus 1 is 2.
4,
6, 9,
14,
28.
71 is quartile 3. The answer is 5. Again, though, it's not about did you guess it right, Adrian. It's about did you know how to get it. All right, you're going to want your calculator for this. Make sure you have your calculator ready. We are going to go to a calculator. Calculator, please. Calculator. Excellent. This is asking us to run a test. How do I know it says to run a test? In the question. Like, look at the end of the paragraph. Is there convincing statistical evidence? It even gives you this. What is that? Our alpha level, right? All right, so that's our cutoff. So it's literally saying, do you know how to run a test? Let's set it up. We don't have to actually do any of this, but I'll just let you know, as someone who can get a lot of these correctly, I think this helps set your test up. So I do the hypotheses. Okay, let's see. What kind of test are we running? It says the average number of hours. So when I see that average word, what am I thinking? I'm thinking means, very good, not proportion, so not a z-test. Possibly a z-test. Doesn't look like this is talking about two quantitative variables. That's when we did the linear regression t-test, so we don't have to worry about that. So really, it's some type of t-test. How many samples do we have? Just says there's one, right? A random sample of 400 teachers. Looks like this is as straightforward as it comes. One sample t-test. So right now, what do we think is the average number of hours worked at a part-time job for these teachers? 13. It says the average numbers hours worked per week, part-time jobs, 13. Okay? They're saying they're bumping up the teacher salaries to try to get teachers to stop doing that, right? Because they can't devote as much time to their students if they're working another job, right? So they did this, and then they want to know if the average number of hours per week has decreased after they did this salary bump. So what am I going to put for the alternative?
Less than.
Less than, right? Decrease, so going down. All right. We have some other things here. We have a sample size of 400 teachers. Our sample mean, I put Y bar, is 12.5. And the sample standard deviation was 6.5 hours. All right. Are we ready to run the test? Yeah? Okay. Let's do it. Remember, you're using your calculator, so turn your calculator on. Is it still working?
Yeah.
Keep going. I've ordered more batteries for next Thursday, so if it runs out during the test, you can replace them.
How much do they cost? Batteries?
I did, yes. AAA batteries. They are AAA batteries, yes.
I thought it was like this thing right here.
What's wrong?
The what?
What's wrong?
Rechargeable battery. Yeah. But rechargeable battery. Oh yeah, it's because there's a charger at the top. Or AAA.
All right, ready? Ready? There we go. All right, here we go. We're going to go to stat. All right, so go to stat. I need that scalpel. Stat. Okay, so stat. We're going to go over to test. So go over to test. All right, and what type of test did we say we're going to run?
One sample t-test.
A one sample t-test, which you can look up here, right, is number 2. Which one are you never going to do?
First, wait. Yeah.
Never number 1. Don't do it.
Never do Z-test.
Never. If you're going to do a z-test, go down to 5 or 6 where it says 1 proportion or 2 proportions. Okay? Never number 1. You click number 1 on this, yeah, you're wrong. Okay.
What button? It's second.
Nope.
And
Didn't hit second.
not
Stats. I just hit the arrow over a couple of times. I've done minimal work.
Oh yeah.
I love these guys.
Wait, where do we get these?
Number 2. We're going to input the stats. See where it says data right here? This would be if they gave us the list of those 400 data values for how many hours that they picked, or excuse me, that they worked in their second job. Luckily, they don't do that, right? I don't want to type in 400 data values. So go over to stats and hit enter. All right, so now it pops up the stuff they did give us. Do I need to go back?
No.
No? Okay. All right, what do we say? Yes, I do. Okay.
Oh. What? Wait, what? Go back.
All right, ready?
Oh, go back to the problem.
Ready, Kenya?
Yes.
Stat. Over to test. number 2.
Oh, it's not really.
T-test. And then if you're here and it says data, if yours says data, wait for it. If yours says data, hit over to stats, hit enter. So to the right to stats, hit enter. Okay, what are we saying is our null hypothesis value for the population mean? 13. It's always going to be equals. What is our sample mean from those 400 teachers working the part-time job? Y bar was 12.5. It's not going well, Marco. And then the standard deviation? 6.5. Marco, you got this, man.
I did not say anything.
I know, that you were like worried. Sample size?
400.
400. Okay, and then what are we picking for the alternative hypothesis? Less than. So go over and hit enter on less than. Hit down and then enter on calculate.
Oh.
Yeah, clear's not the one you want to hit. You want to hit enter. All right, what was our test statistic? Our t-value? Negative 1.538? All right, so we have a t-value. What is our p-value?
0.124.
I got 0.062.
Oh, yeah, I got that.
That's what I got.
Oh, no, okay, yeah. Okay. That's all right. Can you watch the video again? All right, so what are we saying if you compare our p-value to our alpha level?
It's higher.
It's higher. So what does that mean if our p-value is above alpha?
You must reject it.
Do we have enough evidence to reject? No, we don't. So let's look at our answer choices that say no. The p-value of the appropriate test is greater than 0.05. Now, that is one of those questions that many students in the world that take this test will think that is super easy because they know how to type it in. All right? You guys are at a disadvantage because we didn't use these. All right? So if you want to get this right, you got to practice it. All right? No, I don't like using them, but next year I will. Because I have it on my phone now, thanks to Eder. Because we can use them at Arelli without using them. Does that make sense?
Yeah, pretty much.
Typical cat. He created it. All of the downloads that we just did, just cha-ching, cha-ching, his bank account. All right, 26. 26. I'm really hopeful that some of you got this right and got it right by not guessing. This is looking at a probability distribution. Gives you a table, and it's asking for the mean. Do you remember how we did this?
You multiply the
Yes.
numbers.
You got to be more specific. Okay, so the expected value is 1 times 0.56 plus 2 times 0.28 plus 3 times 0.08. You okay? I read this question, I thought, wow, that is the simplest way they could ask this question.
It's like so easy.
Don't overthink it.
Mr. Ryder, how does someone get money from downloading a free app?
Ads.
Pretty much.
Yeah, pretty much.
Pretty much like that.
Wait, so no, that's the only way? Like if they run ads basically?
Listen, I
Or
don't
like,
know.
And if they have currency in the game or something?
Yeah.
Okay. Makes
I
sense.
think I don't know what other ways to do it.
Yeah, I was
What a great question for the classes you're going to take in college, right? I think there's a class out there that's about how to make money off an app.
Yeah.
Take it, enroll in it, pay money, and take it.
Pay money?
That's what classes cost in college.
They don't take Bitcoin.
They don't take what? Bitcoin? I don't know. All right, I don't know what the answer is. What's the answer?
Hey.
Pretty much.
It's C. Thank you. I was like, it's definitely not A. Kenya, do I need to type this into the calculator? Or you got? I mean, you just type it. All right, 27. All right, here's that whole experiment thing, Adrian P.
Oh, there it is.
I could find video proof of me saying something in this class that would help you answer this question. So if you get this wrong,
It's not your fault.
it's not my fault. The one a couple ago, I don't know, it is my fault. I'll take blame for that one. But this one, it's your fault.
What was the one a couple of them?
I'll take responsibility for the calculator button pushing.
Oh, okay.
Right. But this one, no. This one's on you. Do you remember when we talked about blocking? Blocking.
Yes.
This is where you take all of your random sample that you're doing the experiment with, or your volunteers, whatever it is, right? However you got these people, okay? And you're splitting them up based on something. How are they blocking in this one? By age. So the cutoff was 40, right? You're under 40, you go into this block. You're over 40, you go into that block. Now the key thing about blocking, guys, and if this question happens on the AP exam in 9 days, you'll get this right. The key thing about blocking is that I want you to treat each of those blocks, you guys visualize it? People under 40, people under 40, over 40. The key thing is that within those blocks, you're going to run 2 separate, unique experiments. Okay? So this block of under 40, I need to randomly assign the treatments to these people. These people over 40, randomly assign the treatments to these people. Do they have any type of interaction with each other? No. It's like they're completely unique, completely separate experiments. If you know that, you get this right. It's not A.
What did I say? What did I say?
So that was the key thing I was trying to get across when we talked about blocking in chapter 13.
I think the word that I was looking for was treatment.
That's what I said when you asked, right? When you see random assignment of treatments, that should cue your brain. It's an experiment.
No, I asked you the opposite. I would ask you, what should I think of experiments?
Random assignment of treatments.
Oh,
That's it. That's what I said, yeah.
Oh, I remember.
Random assignment of treatments. If you're not thinking that, you won't get it right.
Well, I got it right this time. You don't even have your paper out. But I told you the answer before you said.
All right, let's try number 28. I like this one a lot. It's, I think you can get this right even without being in a stats class. Right? It's just your understanding of probability that you probably learned when you were in like 8th grade. All right? Too long ago. All right. Now, the thing that I noticed about this was the fact that they have a board game that has die that has 8 faces. Weird, right? Usually I'm thinking 6. That's okay. No worries. They tell 3 are red, 3 are yellow, 2 are blue. So if it makes you feel better, right, if it makes you feel comfortable, you could write the probability that it's red is 3 out of 8. Probability that it's yellow is 3 out of 8. And then blue is 2 out of 8. I mean, I don't write this stuff. I just do my work. But if that makes you feel better, right, to write down some info. Now, here's the weird thing. In the game, you toss the die, right? Do the dice move, okay? Until blue lands face up. All right, so you're like, yeah, blue. But here's how they calculate your score, I guess. The number of tosses before that one is counted. So if you do that on the 3rd one, then it actually counts as 2. That make sense? I know, it's weird. You would think you would count all of them. But like if you toss the blue dice, it lands blue. On the 6th one, you got 5 was the number that you count. It's always one less.
One less.
I know, it's just to like try to confuse you. Literally, that's all they're trying to do. Okay? So when it says toss number 1 was yellow, all right? Toss number 2 was yellow. Toss number 3 is red. Toss number 4 is blue. That means
3.
That means 3. Everybody good? Okay, all right. Now, they even underlined it in the question. What is the probability that a player will toss at least 2 before blue lands face up? And I was trying to preach this to you guys. When you see the word at least, you need to think a different way. All right, so let's talk about what at least 2 would be. So what are some numbers for at least 2? 2?
1.
No, at least 2. 3, 4, 5. See where we're going with this?
Yeah.
So what's not that?
1.
Or?
0.
So the probability of Remember, 0 means that they rolled blue the first try.
Yeah.
So at least 2. I write this as 1 minus probability that they get it. Let's see, blue. What do I want to say? Game. I'm trying to figure out what I want to say. Because I don't want to say rolls, right? Because the game counts 1 less. So let's say it's count is 1 or 0, right? The idea is that if I roll blue on the second one, or if I roll blue on the first one. So I'm going to find those probabilities. Let's do that. So what's the probability that I go not blue and then blue? Because that would be like 1 roll. I know it's not right, it's 2, but we're counting 1. So what's not blue? I'll go back. Okay, thank you. I was going to just go here. What's not blue? 6 out of 8. Yeah, red or yellow together, right? 6 out of 8. So 6 out of 8 times what's blue? 2 out of 8. So we'll get down here in a moment. All right, and then I want just blue on the first one, right? Because that would be a counting of 0 rolls if I rolled on the first one. So what's the likelihood that I go, boom, blue? 2 out of 8. Nice. Okay, let's get this one. So what's 6 eighths times 2 eighths? I think we can reduce this, right?
Yes.
What's this reduced to?
3/4.
3/4. 1/4, right? So 3/4 times 1/4 is 3/16.
Wait, what did you add?
I'll write it. 3/4. Are you lost? What are you lost about?
I thought the denominator stayed the same.
That's if we're adding or subtracting.
Oh.
Multiplying, just multiply straight across. Adelaide, where are you lost? Okay.
Multiply. Oh, 1 times 3.
So let me try to get Adelaide back here, right? The idea is that this 3 out of 16 number is the likelihood that you're going to go red or yellow on the first one, okay? And then I'm going blue on the second. That's that number, 3/16. Okay? This number here, 2 eighths, hopefully you see it just, boom, I rolled a blue right away. If I add those together, all right, so what's 3/16? Here you go, Juan, this is what you're talking about. If I add those together, how would I rewrite? Nice, Marco, how would I rewrite this? So 4/16 plus 3/16. Now we're keeping it the same. 7/16. What is this answer? Because that's not the answer. What is that answer?
Less than 1/2.
No.
Oh, it's the wrong answer.
It's the wrong answer because that number, 7/16, is the likelihood that I roll a blue on the first one or I roll a blue on the second one when I didn't roll a blue on the first one. Okay, it's those two together. So to answer this question, right, at least 2 or more, I'm going to take what I just found and subtract it from 1. So what's 1 minus 7/16? Now I'm just going to write 9/16 first. Right, so that's my answer. And I go up to this one, and which one is it? Is it D?
Oh, it is 16 minus 7.
Okay.
We know.
Again, I think, and maybe this is not me, right? I'm not 17, I'm not 18. But when I read this question, I think what confuses students
Bless you.
thank you, is this idea that you don't count all the rolls. That was just weird to me. Okay?
When has that happened to you 3 seasons in a row? Most I've done is 2.
I don't know, I'll start keeping track of my data. And
Well, I don't know.
Let you know.
I've done it so many times, like sneezing twice, and it's never been a 3rd.
okay, right? Jill, forget what J Beep says, right?
Never say always.
That's it. Okay. 29, last 2, then we're done. Let's do 2 more.
I used to use it. What does that mean?
Once we finish these last 2, I'm going to show you guys an email that you should have gotten on Friday, all right, about IXL. If you want to, somebody said, oh, I thought I had time to prepare. This is what you can do if you want to prepare.
I saw like 7
Great. These questions will be a little different. All right, let's do type 2 air. All right, here we go, guys. You know when my brain reads this question, what do I ask my brain first?
Type 1 air.
What's type 1 air? That's the way I always do it. It works for me. If it doesn't work for you, then just go straight to type 2. So I know that type 1 air is when you reject the null hypothesis in favor of the alternative, but you did the wrong thing. You shouldn't have. All right, shall I write this down?
Yeah.
Okay. I mean, you're not going to, right? But I'll do it.
Oh no, I was gonna write it down.
This is like a dig right at Adrian. That's it.
Oh, okay.
So type 1 error is rejecting the null when you shouldn't have. His name is Mr. Adragna.
I just call him a dragon.
I'm sure he appreciates that.
But when I say to his face, I say Mr.
Whatever. Yeah, Mr. Dragon roasts us.
Yeah.
He roasts you guys?
Yeah.
Oh, you know that it's all out of love, right?
I don't know. Sometimes it seems like literal, like it seems like actual.
It's really just because you remind me so much of my friends in high school, and it's just like I hate when people waste like ability. It bothers me. Like I used to get so mad at my friends, like, "Why don't you ever study, man? You could do so well." It's like, I'd rather play video games. Type 2 error. That's where it comes from. That's where it comes from. I'm saying you're wasting. Like, of course I play video games. Come on, man. How old do you think I am? Type 2. Type 2.
32 or 26.
Those are the options. Can we do type 2 error, please?
Yeah, oh yeah.
Type 2. So I just go the other way. Type 2 is when you fail to reject the null when you should have. I know, this is not easy stuff, man. This is not simple. So when I look at this question, it's saying which one is a type 2 error. All right, I'm saying that I'm failing to reject 64. So I still think the population mean is 64, when in reality, it's actually above 64. That's what this question is saying. All right, so I still think it's 64, when in fact, it's not. It's above 64. So it's not going to be these two, right? Because we're talking about failing to reject. Failing to reject the population mean. So it is B.
Wow. I want to see if statistically.
What's
Statistically?
7 more classes, Fatima. 7 more classes. But in the last class, there'll be no boys. Number 30.
I thought it was after lunch.
Oh, sorry. Some of the boys will leave in a few hours, but all the boys will be gone for the last class. You're right. I'm still going to be here. Last one, 30. All right, we have a 2-sample T interval for a difference in means, and they're going cotton candy minus mango. Cotton candy minus mango. That's what they're telling us, okay? So we're doing the average of cotton candy minus the average for mango. They're talking about different flavors for ice cream. All right, so you participate in this group where you get randomly assigned one of the 2 flavors. You don't know which one is which. You probably do once you taste it, though, right? And you're going to say 1 if you really dislike it, and you're going to say 5 if you really like it, or somewhere in between if you're not there. Make sense? Okay. So now we're doing an interval between these 2 groups. All right. It says there was convincing statistical evidence of a difference in the population mean of these flavor ratings. I have been asking you guys this question so many times. All right. If we assume there's no difference, what happens when you subtract these means?
0.
You get 0. So if there is a difference, statistically, what should I not see in my interval? I should not see 0. I should not see 0. Notice how I see 0 on that one? Yeah, so that's not the answer. Neither is A or B. I'm not sure how they got those numbers, right? Because we're talking about the average of 1 to 5. What's going to be the average between 1 and 5? Somewhere between 1 and 5. So I'm not sure how they're getting these numbers, right? The numbers will be small. Okay, still with me? All right, so now we've narrowed it down. So the question is, it says they're convincing statistical evidence that mango has a greater sample mean. So let's make up a number. Make up a number. No, the average between 1 and 5 for cotton candy. Let's use 2. Let's pick a number that's greater than 2.
3.
Sure.
4.
What happens when you do this subtraction?
You get a negative.
You get a negative.
So it has to be. This is literally only vocabulary.
Statistical.
It is very much not math. I agree.
All you have to do is really understand vocab and stats.